Welcome to the session on computer science and IT at RMIT University. My name is Professor Karen Verspoor, and I am the Dean of the School of Computing Technologies at RMIT. And today I'm going to tell you a bit about the computer science, information technology, software engineering, and data science programs that we have here at RMIT, IT at RMIT. These programs are world-renowned and allow students to work across a variety of disciplines to replicate the real-world experience that they will need once they start their careers. During this presentation, there are moderators available to answer any questions that you have via chat. You won't be able to speak the questions, but please try to type your questions via the chat function and we will try to get back to you. At the end of my presentation, I will also try to answer some of these questions live. Before you add a question, please have a read through all the questions that are already there. If there is a question that has already been posted that you are also interested in, please feel free to give it a thumbs up. And that way we'll know which ones to prioritize at the end of the presentation. Next slide, please. Before I start, I would like to acknowledge the people of the Woiwurrung and Boonwurrung language groups of the Eastern Kulin Nation, on whose unceded lands we conduct the business of the university. RMIT University respectfully acknowledges their ancestors and elders, past and present. RMIT also acknowledges the traditional custodians and their ancestors of the lands and waters across Australia, where we conduct our business, and where I'm joining you from today. Next slide, please. RMIT is committed to redefining its relationship in working with and supporting Aboriginal and Torres Strait Islanders' self-determination. The university's goal is to achieve lasting transformation by maturing its values, culture, policy, and structures in a way that embeds reconciliation in everything we do. In line with the principles of Bunjil, we are changing our ways of knowing, working, and being to support sustainable reconciliation and activate a relationship between Indigenous and non-Indigenous staff, students, and our community. And if you take the opportunity to visit RMIT, on campus you will find a number of cultural artifacts that relate to the Indigenous peoples. And this includes the artwork that you see on the slide here. So we invite you to join us on this journey. Let me go ahead and tell you a bit about our programs in computer science and IT. Next slide. Did you know that RMIT was founded in 1887? I think at the time it was known as the Workerman's College. And in fact, that notion of working is really ingrained in the RMIT way of teaching and learning. We value very much the education that involves skills, real-world skills, and the application of those skills to allow our graduates to be job ready and make a difference in their world and to have productive careers. We are Australia's largest tertiary institution. We work across 5 campuses in Australia and even in Vietnam. Particularly in Vietnam, we have 2 campuses in Ho Chi Minh City and Hanoi, which you may not have realized. And this actually gives our students opportunities to study in different places that other students at other universities may not have access to. Furthermore, we're connected worldwide with over 450,000 alumni and 200 university partners around the world. And so global exchange is a real part of your opportunities at RMIT. Next slide, please. We have campuses in the city, in Bundoora, and in Brunswick in Melbourne. And as I mentioned, we have 2 campuses in Vietnam. Most of the studying that you would do in computer science and IT happens in the city. So the core of our work happens right there around Melbourne Central on Swanston Street. And that is really the heart of our operations. But we do have access to facilities, particularly engineering and science facilities at the other campuses that you could potentially have access to if you were interested in going in that direction. Next slide, please. So let's talk a bit more about IT and computing at RMIT. Okay, next slide. All right, who knows who these guys are? Anyone? I'll give you a hint. They're pretty famous and they're pretty rich and they've been pretty successful. These are the Rolling Stones. Now, I see you thinking, well, I don't see you, but I imagine that you're thinking, why is there a picture of the Rolling Stones up on the screen during a presentation about IT and computing at RMIT? Curious, right? Next slide. Next slide should give us a bit of an answer. Well, the answer is they have been doing what they've done since the 1960s. The Rolling Stones have had to adapt and change over the years. And in fact, that makes them a little bit like people who study computing, because computing is a field that has changed drastically since the 60s and really looks nothing today like it did back then. Back then, and we got our first computer at RMIT in about 1962, the computer took up an entire room and needed its own special air conditioning and ventilation system just to run. And now you carry around as much power as that computer had in your pocket, in your mobile phone. The amount of technology that we have around us in the world just keeps changing and growing, and our ability to harness the power of that technology keeps moving and shaking as well. So like the Rolling Stones, we're movers and shakers, and we got to keep on doing what we're doing in order to be successful. Adapting and innovating, that's what computing is all about. Many of our programs are focused on industry collaboration. We work with industry in the context of projects and give our students opportunities to tackle real-world problems and real-world questions. They may be in collaboration with leading tech companies or some of the smaller companies that we're surrounded by in Melbourne that focus on technology and data science. Our programs are designed to be one step ahead of the future industry demand. We're always balancing the need for foundational knowledge that will give you the capability to have a foundation for learning new things and keep on adapting in that changing world, with the need to have skills as soon as you finish your studies and walk out the door. The education that you can get in computer science and IT is among Australia's top programs. We have a globally recognized and an accredited program, accredited by the Australian Computer Society. We're in the top 10 universities in Australia, according to the QS World University Rankings. And one of the key things that we offer you is flexibility. We want you to build a flexible skill set. And in order to do that, we have to give you flexible degrees. And so you can combine your different interests into a degree program that really matches your passions and your talents. We offer a number of different specializations that have been developed in order to reflect current IT trends, such as in artificial intelligence, cybersecurity, and so on. Next slide, please. So what do we offer exactly? We offer a Bachelor of Computer Science, a Bachelor of Software Engineering, Bachelor of IT, and a Bachelor of Data Science. And you can also enter into these bachelor's degree by an associate degree of Information Technology, which leads into the Bachelor of IT. These are the key programs at the undergraduate level at RMIT. Next slide, please. To give you a sense of the entry requirements that are needed to get into these programs, we've summarized them on the slide here. So as you can see from this, these are just the indicative ATARs that were used at the lowest rank at which our students received an offer. Now, of course, this is just indicative. It could change this year, but it gives you a sense of what the expectations are for the different programs. And you will see that computer science and software engineering have a somewhat higher HR expectation as compared to information technology. Data science is our newest program and was just started this year. And so there's a little bit less certainty about exactly where that one will land, but this year's HR was just above 70. You can see here that the requirements for these different programs are a little bit different. So for computer science and software engineering, we do expect that students have been taking math methods or specialist maths and that they obtain at least a 25 in those subjects. Information technology and data science have a slightly lower maths requirement, and so students entering those programs are only required to have some maths and a minimum of a 20 in that maths. And that reflects differences in the level of mathematics that's assumed for the different programs. In IT, you can and data science. In data science, you'll be upskilled in some of the maths if you haven't had methods. And in IT, it's not as critical to some of the offerings in that program. Next slide, please. Now, you'll ask, what's the difference between computer science, software engineering, and IT? And well, the answer is it's a little bit like which flavor of ice cream do you prefer? Because actually there's a lot of overlap between our different programs. And whether you study IT or computer science or software engineering, a lot of the core courses that you will take, a lot of the core knowledge that you will gain is very much in common. And so it's a little bit like whether you prefer chocolate chips or peanuts in your ice cream, whether you prefer mint flavor or vanilla, and really less like whether you want ice cream or maybe you would like a crème brûlée instead. So what we're offering is ice cream, but we have different varieties and flavors of ice cream. And in fact, the flexibility of our programs means that even within the programs, there is quite a lot of choice about exactly what you study. So we encourage you to explore a little bit and try different flavors and see what really suits you best. Next slide, please. Let's go into a little bit more detail about the different programs. So in the Bachelor of Computer Science, we focus on the technical skills that are needed to become a technical specialist in computing. And so we teach the theoretical and algorithmic foundations of computing. And we really work on honing those programming skills. And we make sure that all of our students are given the skills that they need to be successful in technical development work in the technology sector. So students who study computer science can expect to be able to design and implement and maintain complex software systems. And they may be interested in pursuing some of the more theoretical and advanced artificial intelligence or machine learning, cloud computing, games and graphic design kind of algorithms in order to really build very advanced systems. If any of you were on the session earlier today with Hugh Williams, one of our alum, he talked about search algorithms and designing systems that use infinite scroll to allow you to keep looking at information without having to scroll next on a page. Those are the sorts of algorithms that our computer science students will learn about. Next slide, please. The career outcomes that you can expect from a Bachelor of Computer Science include, of course, software developer and web developer, but they can also lead to systems architecture type roles where you're designing those complex systems, and even having a security specialist type role where maybe you're responsible for making sure that your company is secure against hackers. And if there is an attack or someone hacks into your systems, you'll be the person that they would call. Next slide, please. In the Bachelor of Software Engineering, We build on those same foundations as in the Bachelor of Computer Science, but it explicitly works towards large-scale software engineering in a team-based context, recognizing that in the real world, most software development is done in teams and actually requires coordinated effort across a number of people in order to build the big systems. And so the Bachelor of Software Engineering actually shares the first 2 years in common with the Bachelor of Computer Science, but then adds an internship in the third year for 12 months that gives our students exposure to the real world problems of developing software. And so it gives our students the opportunity to learn about the real world implications of some of the things that we would have taught them in those first 2 years. Things like how to write code that has good documentation so that somebody else can read that code and pick up on it. How to understand user requirements and actually build a system that meets a particular user need. And our students then take that real world experience and come back in the fourth year and really further their experience and learning around detailed project work in that team-based environment. So you'll be learning how to design, code, test, and manage large and complex systems in this degree. But it does start with that programming foundation. Next slide, please. The kinds of skills and jobs that we can expect from a Bachelor of Software Engineering in some respects are overlap with what we would see from a computer science student, including software developer, programmer, and so on. But you may also specialize in customer needs analysis and user-facing design, or you may take the route of becoming a project team leader where you coordinate the technical activities of a large group of people. Remembering that software engineering is all about teamwork. Next slide, please. Bachelor of IT is a more flexible program and has less of an emphasis on programming, unless you want to emphasize programming. So remember, if you like those chocolate chips, in other words, if you like programming, then you can choose to do that. But there are many other choices available in the Bachelor of IT. So you can work in web and mobile computing, learn about security and cloud computing, learn about data management, do software systems analysis, even a bit of AI. And it gives you much more options around business applications. So for instance, if you are interested in trying to advise a company about what the best approach to implementing a particular IT system is in their business context, taking into consideration the business requirements, IT might be for you. It's about adapting and applying IT infrastructure and technologies in a variety of problem contexts. For instance, in e-commerce, how do we leverage IT systems? How do we leverage the web in order to support a marketplace for products? That would be the sort of thing that an IT student might do. They need technical understanding, but they also need some business understanding, perhaps some design or some infrastructure focus. Next slide, please. The career outcomes that our students have from the Bachelor of IT include roles like software tester, again, software developer or web developer, but also system or database and web administration. So managing these systems, maybe not developing them, but making sure that they're up and running and working effectively. They also land in IT support roles because they understand the technology and they can help troubleshoot it. Quality assurance engineer is another kind of role that our IT students will get. Maybe you become a software tester that really examines or tries to break a piece of code and figure out what works and what doesn't work, so that you then feed that back to some of the developers who can fix the problems. Next slide, please. The Bachelor of Data Science, as I said, is our newest program. And this is really, like it sounds, about working with data. You would learn to analyze and manage large quantities of data coming from lots of different sources. And importantly, understand how to use that data to gain insight, and they may model the data and make predictions, and also to effectively communicate your work to technical and non-technical audiences, because there are many companies these days that rely on data science in order to make decisions. And so the role of the data scientist is really to take all that data, massage it, and try to make inferences that can guide particular decisions. Maybe if you're working for a supermarket, you might want to try to predict the demand for a particular product on your shelf so that you know whether or not to order more. That can come from examining previous sales. And so you can leverage the data that you have in order to make predictions about the future. Next slide, please. So the kinds of careers that a data science student might expect would include, of course, a role as a data scientist, but also business intelligence and business analytics. Perhaps a web analyst kind of role where you're looking at how people are navigating through a particular website, or understanding a bit about the market for a particular technology. You might become a data architect, somebody who designs the systems that collect and massage and analyze the data. Or you might focus on visualization and interpretation of the data. Next slide, please. It's important for us to talk about pathways into our degrees, and the key pathway that we can offer students is through an associate's degree in information technology. So the associate's degree is a 2-year degree, which has somewhat lower entry requirements than the Bachelor of IT. But it articulates into our Bachelor of IT degree, which means that if you complete the associate's degree in information technology, you can move into the Bachelor of IT and finish with just a 3rd year of study. You can obtain your Bachelor of Information Technology. There are pathways into other programs out of the associate's degree, but they require a little bit more than that extra year of effort to get the bachelor degree. Next slide, please. As I started off saying at the beginning, one of the real important things at RMIT is our industry connections. We really focus on giving our students experiences that are realistic and prepare them for work. So we have work integrated learning opportunities, including projects that are led by industry partners, and you will have opportunity to do work placements as well, or receive mentoring by industry professionals throughout your studies. In 2020, 15,000 students at RMIT undertook work integrated learning placements with over 2,000 global industry partners. And this year, with the pandemic, we've been seeing students do virtual placements with industry partners from all over the world, including in Europe and in Canada, and of course, right here in Melbourne. So lots of opportunities in that space. Next slide. The kinds of projects can vary. As I said, sometimes we have projects that are industry inspired. So maybe the problem comes from an industry partner and you are working on solving what's a very realistic problem in the context of your studies. But you can also have an actual industry placement where you go into an organization and experience working directly in the context of their environment. And of course, those give slightly different experiences, but in all these cases, we really aim to provide those realistic experiences. Next slide. We have connections globally, and the global experience is really something quite special at RMIT, particularly because of our campus in Vietnam and because the Bachelor of IT is offered in Vietnam. it's possible to go and actually study RMIT courses in Vietnam with no loss of time. We have relationships at the university level with universities all around the world, and so you can organize exchange programs that allow you to go and study in other places. Now, of course, we don't control the borders, but we're hoping that some of these opportunities will open up again very soon. Next slide. I wanted to mention that we have a couple of new scholarship opportunities that are going to be made available, and they're actually going to be open for application from now. So we have a brand new scholarship with a company called Pepperstone, and they've been joined by a company called Build Exact, which is a scholarship that will provide $15,000 per year for the duration of the program, and includes a internship, a 12-month internship as part of the studies with the companies that are sponsoring the scholarships. And these are aimed at diverse or disadvantaged students. If you're interested in this, please see the webpage to learn more. But we're really hoping this gives some students a chance to study IT when they might not have otherwise been able to. Next slide. We also have the Westpac Young Technologist Scholarship, which is a $5,000 per year scholarship for 3 years. And has some specific eligibility criteria that you can read about on the webpage. So I wanted to make sure you knew about these opportunities. Next slide. I think that's actually the end of the formal part of the program, but I've been noticing there's been lots of questions coming through on the chat, so I'll start to tackle some of those now. If you have questions that I haven't answered in the presentation or that you don't hear the answer to in the next few minutes, please keep adding them into the chat. So the first question I'll tackle is, what subjects do I need to do in school for a Bachelor of Computer Science? In particular, do I need methods 1 and 2 for doing computer science? And well, you need methods 3 and 4, or you need specialist maths. So you need to do the exam for one of those in order to enter the Bachelor of Computer Science or the Bachelor of Software Engineering. As I said, though, if you haven't done that, then you can still study IT and computing through the Bachelor of IT. You do need a maths, though. So if you haven't done any maths at all, it's going to be harder to find a program that suits you. Are there any pathway entries for the degrees? Yes, so as I mentioned, we have an associate's degree pathway that allows you to transfer into the Bachelor of IT. And from the associate's degree in information technology, it is also possible to go into some of the other programs, but there will be less credit that's offered for that, and so there'll be a little bit more to catch up on to end up with a bachelor's degree. Will you be able to work in cybersecurity with an IT degree? Yeah, absolutely. So cybersecurity is one of the key areas where we offer electives, and we already offer courses like security testing, and we're developing new courses in blockchain as I speak to you. And so there should be increasing number of opportunities. But yes, cybersecurity and understanding of how to protect systems is one key aspect of our IT offerings. And indeed, some of the fundamentals that we teach in computer science, things like encryption and data privacy in the data science program, also address different aspects of cybersecurity. So there are a number of different ways to become aware of the factors relating to cybersecurity. What's the fundamental difference between Bachelor of Computer Science and Bachelor of IT at RMIT? Well, as I said, they're different flavors of ice cream. But the real the real difference is that in the Bachelor of IT, you have a bit more flexibility. So computer science is more oriented towards programming and development of the technical knowledge related to computing, whereas Bachelor of IT has less of a requirement to do the programming. Having said that, you can, of course, get quite deep into programming in the Bachelor of IT. But there are more electives in the Bachelor of IT, and so there's a broader set of things to choose from in that degree. A related question is the difference between the Bachelor of Computer Science and the Bachelor of Software Engineering. The two programs share the first 2 years. They have very much in common in those first 2 years. The main difference is that the Bachelor of Software Engineering includes the 12-month internship in order to get real experience in building large-scale software systems. And the focus in the 3rd year of study, which is the 4th year of the Bachelor of Software Engineering program, is on team-based large-scale development of systems. In computer science, there is less of an emphasis on that large-scale system development, and students can explore more advanced algorithms and technologies like games and artificial intelligence in their final year of study. Another question that came in is, can I do Master in Artificial Intelligence after doing a Bachelor of Computer Science? The Master of Artificial Intelligence, which I haven't really told you anything about, but good for you for finding out that we do offer that program. It's actually offered as a non-cognate degree, which means that we don't expect that students have a Bachelor of Computer Science coming into that program. On the other hand, if a student does have a Bachelor of Computer Science, they can get advanced standing into the master's degree and essentially do more of the advanced courses in the master's program during their studies. So yes, absolutely, you can come into the Master of AI after doing a Bachelor of Computer Science, but you don't have to. So there, you can come into the Master of AI, and basically you'll get a crash course in some of the core elements of the Bachelor of Computer Science if you don't already have that background. Question: do these degrees have anything to do with virtual reality? Well, virtual reality is driven by computing. So if you're interested in virtual reality and you want to know how to build and use virtual reality, well, you probably better study computing or IT. Because the skills that you will gain in the program will allow you to learn how to build and really use the virtual reality systems. In the games program, in our games courses, you will learn how to create simulated environments, and that's really what virtual reality is all about. And that's quite complex because it can require development of graphical environments, environments that leverage AI because there's an interaction between the machine and a user. And so yes, indeed, the virtual reality has everything to do with computing and IT. What sorts of courses would you recommend that have a focus on computer and IT hardware rather than programming? So the hardware side of things is more in the electrical engineering and network engineering part of RMIT. So you would find programs that emphasize hardware in the School of Engineering. We offer some networking courses in our programs, but primarily we focus on the software side of that. So for instance, how does information travel between systems? How does information get communicated from between two computers? So in the context of cloud computing, for instance, we really need to understand how information can travel between machines. But the emphasis there, even though that communication happens over a cable or maybe over a wireless connection, the emphasis is very much on the digital representation of the information and how that information is transmitted between the two computers. If you're more interested in the hardware, you might want to look at engineering. Okay, I think that might bring us to the end of our questions. So with that, I will close up the Q&A. But I'd really like to thank you for joining us today and learning about our programs. If you have more questions, please don't hesitate to get into touch, and we will do our best to try to answer the questions. Thanks for joining us today, and best of luck with your future studies. Goodbye.